Welcome, everyone. Thanks for joining us, and thanks for being part of our community. My name is Valon Kolika, and I'll be your host for today. Just a few reminders before we kick it off. If you have issues viewing the stream at any time during this presentation, please, and you're using the web browser that is of Teams, please refresh your browser. If you're using the desktop version of Teams, you can just simply exit and rejoin. This seems to solve most of the connection issues. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window, simply by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, or even questions related to the product not related to this topic, you can post them at Azure Network Security Forum at aka.ms/Azure Network Security Community. We love to hear your feedback on how we can improve on these webinars, and to do so, you can go to aka.ms/security-webinar feedback. And by the way, all the links that I'm announcing or that I'm verbalizing here have been already announced and shared with you at the chat window at live event Q&A. I would also like to invite you to join our public community by visiting aka.ms/security community. That's the best way to ensure that you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for at aka.ms/securityprp. In there, you can request features, give feedback, review our product roadmaps, register for events, or just simply join for webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Mohit, Kumar, and Tobi Otolorin will go over the protection and detection capability of Azure Web Application Firewall using attack simulations. Both Mohit and Tobi are program managers with our Azure Network Security GTP team. And without further ado, I will pass the mic to them. Mohit, Tobi.
Hi, everyone. Thank you, Velon. My name is Tobi. I'm from the Customer Experience Engineering team. And today we're going to be talking about how to use attack simulation to assess protection and detection capabilities of WAF, that's Web Application Firewall. So Web Application Firewall is how you provide security for your applications, basically on a layer 7. And we are trying to make sure that our customers know all the features that they can use to detect and prevent this attack from coming and getting access to their applications. So today, we'll be looking into a quick overview of WAF again. That's how WAF works. And then from there, we'll talk about the key features. And then I'll show you a quick overview of what it looks like and what to configure for different settings that we have. And then my colleague Mohit will do some demo so that we can have more insights into how WAF actually works. And the demo environment will be such that we will work in a way that we have two applications, and one of them does not have WAF, and the other one has WAF, and then you can clearly see the difference. And then you would have some time to also look into the logs So our log is like our ledger. So every transaction that's happening, we'll be able to have access into it, and then you can see for yourself. And also, and that will give us more access into how to troubleshoot, how to fine tune your environment. So we'll look into all of this during this, and then at the end, hopefully time permits, we'll spend some time to take some questions from our audience. So please feel free to leave questions on the side if you have any questions, and we'll try to attend to them. We have people from our team that are very capable to give you answers concerning this. So without further ado, I'm going to be going straight into it. So this is what the common vulnerabilities landscape looks like in 2021. We are putting the slide there to give you more visuals into what's actually happening in between you and your application. So there's so much injections going on. This wasn't what the graph looked like 4 years ago when the last common vulnerability bulletins were published. So now there's so much injections going on. There's so much broken authentication, cross-site scripting. So basically you can see how it ranks. It's a whole lot of people trying to get access to your illegitimate access to your application. There's a whole lot of incoming requests that are not legitimate. So how do we specifically block out the illegitimate request and grant access to the legitimate request? How do we reduce all these scripts and bots all over the internet from overwhelming our resource? So these are the kind of things that we're going to be talking about today. And if you stay long enough, you'll see how we have chosen like some of these examples as part of our demo scenario. So you're going to see injection being used. You're going to see cross-site scripting being used. So if you do any form of PHP or SQL in your application, then you are vulnerable to so many of these. It could be from the different various modules. It could be IO streams, SQL authentication bypass, any form of, if you do any form of data input from customers one way or the other, then just know that you're susceptible to this form of attack. The same thing with broken authentication. This is how you allow attackers to, use compromised passwords, keys. The whole idea of broken authentication is session mismanagement, basically. So if you are familiar with like capture the flag, I'm sure you've seen how sessions that have been sustained over time or that are not well managed can be used to exploit like flaws, and you can end up using another user's identity, and you can use that to modify user access. You can use that to gain access to files. So broken authentication is getting a lot of screen time nowadays. Same thing with cross-site scripting. So for scripting, you all know how this happens when you have like disallowed HTML attributes having access, being granted access to the public. If you do not catch certain exceptions in your application, the problem with all of these vulnerabilities is the developer is supposed to write the application, and that's his job. Then if he knows security, that's actually a plus on his job. But the attacker doesn't necessarily have to be a developer. He just needs to know the right tools to use. He just needs to know the right scripts to apply. So while the developer is writing an application and he has to like think of about 100 or 500 security steps that he needs to take, an attacker can just take one script and it will run 50 attack in that recon attack. So in that kind of situation, the ratio of attacks tool is way much more, or it's much more than what the developer can handle in terms of his security knowledge. That's like two people's job all at once. So this is the advantage that WAF brings to the table. There are so many things that your developer would not even be aware of, or why it works, or how to like catch to such exceptions, or how to look out for such vulnerability. Because again, there's like standards being released every time, every day. So what WAF does for you is to block that hole from being a vulnerability opening to the public. So WAF stays. And how do you use WAF to do this? WAF can be either applied via application gateway, front door, or CDN, even though right now we are trying to make sure that customers use front door and application gateway much more. So again, this is what it looks like with if you pass data in and out in any way whatsoever, you depend, again, like I usually say, depending on the kind of application that you have, you're going to be susceptible to one thing or the other. If your application serves file content to people, then daemons like VSFTP, that's a very secure FTP daemon, you're going to be exposed to it. If you have SQL, you're going to be exposed to SQL injection. So depending on what you have, there's like custom made, there's like a menu for every form of application. So it's important that even when you can't keep up with your type of application, that you can keep up with the security. So WAF gives us that. Next slide, please. So basically, WAF ensures that we get legitimate access to the backend workload. So how do we do this? We have the pre-configured OWASP top 10. This is currently being covered by our managed rule set. So if you use WAF, then the managed rule set, which is currently managed by Mod Security, ensures that we have up-to-date the baseline configuration for security. And if you are familiar, we're going to be going more into that. In fact, today's demo will be based on how the managed rule set works, basically. So most of the demo that we're going to be using today will be showing how the managed rule set actually helps you against such attacks. So again, the managed rule set already has like a different form of prevention against this attack, and you can look up the rule ID on the Spider Labs and say, okay, what's this particular attack about? You can get more information. So there's like a reference library that you can use to get more information into how it works. What kind of payload does it come with? What kind of exploit is this, basically? And then when you have an idea and you are very, very sure that, okay, this is because you always have situations where a particular attack might not necessarily be an attack per se. So for instance, if you have applications and let's say while you were developing your code, you try to use a logic that, okay, if 2 equal to 2 here, then do this. One of those situations, one of those things you do to do like a check. In that kind of situation, that could also be misinterpreted as an SQL attack. Or if you use abbreviations like OR for Oregon, these are real life examples I've seen with customers. In such situations, it could easily trigger. So in cases like that, it might be a false positive. So you can actually use exclusions to avoid, to actually prevent that attack to prevent that from being an attack next time. Then we also have bot protection. So this is how there are different types of bot categories. There's the good, there's the bad, there are some unknown bots. So how do you prevent the bad bots from getting access to your environment? So you want to make sure that you have this in your environment and it's turned on and it's working right. And bot protection also works with the Microsoft Threat Intelligence. So this is how we make sure that we're using first-party threat intelligence feeds about the different form of malicious actors, botnets, malware, honeypot. And the beauty of this is the threat intelligence feed is integrated with the Microsoft Intelligence Security Graph, and where we have like human analyst observations, different ways by which information is being updated to make sure that you have most up-to-date information about malicious URLs, different sources of attack. We have information there. So since it's integrated there, you can be sure that malware, phishing, and all of this is being done for you. Other things you can do is you can do conditional rate limiting on the network edge, and also we're going to be using log analytics to get more visualization for more information about where are our attacks coming from. Why are they coming from here? What can we do to them? Can we just block up? For instance, if you're serving an application that is supposed to be for a school environment, you probably don't need any access from like certain countries or like certain geographical regions. You can just say, okay, why am I even getting this in the first place? Reduce this access from here. So this is how you manage and control over time. So when you start, you want to take some time to actually put it in, say, detection mode and see how your environments respond, and then you switch to prevention mode. Next slide, please. Next slide, please. Thanks. So again, like I said, the WAF engine allows us in different ways to manage our environment. So we have the manage rule set, and if you see the picture that I have there, to the right of that tab up there, there's manage rule set, there's custom rules. And in the manage rule set here, which is what we have configured in this view here, this is on the front door, this is a WAF on front door. Once you select, you can use the default rule set, and when you select the default rule set, and also when you're using the core rule set in this case, you can be sure that this type of attack you can see here, you can see the cross scripting, the SQLI, you can see the protocol attack, all of these, you can see once it's enabled, these all have submodules in them. So if you go through the documentation that we're going to provide, we also have, by the way, we also have a blog that details everything that we're going to be talking about today it's a very extensive, about 4 to 5 parts. And I really encourage, if you're really interested, to be broken down in the ways that you can easily understand them. You can go through and set up the environment and simulate this by yourself. So again, the WAF engine, like I mentioned earlier, each of these attacks that you have here, they have like sub modules, and you can look them up in Spider Lab's core reset information. So the way it works is, when an attack happens, we don't immediately block it, and the reason is because you can actually have the WAF actually operates in 2 modes: the traditional mode and the anomaly scoring mode. So in traditional mode, each attack has a score, and that's it. So the score is what is used. When that score is achieved, it just triggers and it prevents. Now in the anomaly scoring mode, what happens is each of the attack has a score, and then we begin to add it together. So cumulatively of that, the cumulative result of adding those scores together, when they reach a particular threshold, is what we use to prevent. So so when you use the anomaly, which is what we use now, the anomaly scoring mode, what happens is we begin to add each of this. So for the most part, we also have different categories. So it could be critical category, it could be just error, it could be warning. So depending on what category it is, once there's a match, once we get to that threshold and there is a match, when there's a match and all of these matches, the scores have been added together and we reach that threshold, then the action that we set up triggers. So do we want to alert us? Do you want it to deny it completely? Do you want it to disable? So we have these modes that we have that you can either say, okay, just alert me, don't do anything, or just deny it on my behalf, or disable the rule on my behalf. So anomaly scoring mode is what's used, and the scores were added together. For example, critical mode is 5 points. So when you have all of these attacks happening and it adds up to 5 points, it begins to deny that particular access. And this is how we try to prevent that access. So again, like I said, you can also have customized action whereby you can say, I don't want connectivity from this particular IP address or from this location anymore. So you can also put that customization there. You can also look into a particular rule, and you can use the URI and say, okay, this particular rule that is being triggered here is a false positive. So you can use that URI, and you can use different parameters. You can use the cookie, you can use the transaction ID. Basically, look for something that is significant to that particular URI, and then use that to create an exclusion and say, okay, when you get here, don't inspect this part. You can inspect all of, so the WAF will go ahead and inspect all other parts, but that particular part will not be inspected. So your manage rule set, once you do that, once you configure that, that's how you actually say, okay, you can go ahead and inspect all of that, but when you get here, just exclude this part. Next slide, please. So, as I was mentioning earlier, it's been an iteration over the years. So we started from 2.29, and now we're currently in preview for 3.2. And what that means is, like, this has been updated over time. And like I was saying before, Sql injection and broken authentication, they weren't the highest in that graph before, but now you can see how voluminous. If you look at the CVE bulletin that has been published about this, is there in thousands, like hundreds of thousands actually. Like I think injection right now is about 150,000. So that's how much information you are contending with. I don't expect any developer to have to like know all of that. So in any way, so it's super important that there's a WAF with some form of core rule set, which is updated to protect you from SQL injection, cross-site scripting, all of this that we have listed down here. So this is something very, very important that we make sure that our customer look into. And you can see in that diagram again, you can see the different modes that we have. So once you enable it, which is the first option there in the right, you can see that highlighted in blue. Once you've enabled it, the next thing is, okay, what mode do you want it to work? Is it detection or in prevention? So in detection, it just detects and it alerts in the log. But in prevention, it actually goes further and takes actions on your behalf and say, okay, this looks like script, or this has already made the anomaly score, and I'm going to stop this from happening. So it's going to stop that attack from happening. So then there you go further. There you configure which particular rule set you want to use, and then from there, you just finish up the configuration. Easy steps. It can be up and running within 5 minutes. So, like I mentioned earlier, there's a blog that actually goes into details into step by step if you want to try that out. And then before I move into the demo, I also want to take some time to talk about our WAF integration. Next slide, please. So WAF, right now you can send WAF data to Sentinel. So if you take log data from the WAF, you can use it in Sentinel to generate pattern and detect anomalies. You can use it to do some if you are using like count-based hunting, you can do that and set some threshold and say, hey, once this reaches a particular threshold or this within a particular time frame, then you can configure a logic response. So you can say, okay, do this for me when this happens, do that when that happens. So this way you can have more visibility into events and incidents. We are constantly working on new Azure Sentinel detections for Azure Firewall. So right now we are using some known IOCs, indicators of compromise. And we're trying to use those to prevent various malware and malicious codes that are used by adversary, for commander control and exfiltration. So we constantly update that. So this is something that we believe that you should take advantage of, because you're going to get visibility into what's actually happening in your firewall environment. We also have playbooks for to configure different form of responses to incidents when they happen. And then also we have the Warf monitor workbook, which gives you visualization. So there you can see what's the most frequent type of injection attack coming into your environment, the geographic location they're coming from, the rates per day. The idea is the more you have an insight into these things, the more work your application, your WAF will have to do, the less work your WAF would have to do. Because if you know that you do not have any business getting any requests from a certain location, you can just block it off. If you feel like this is a request that is not legitimate, you can just restrict access to it. So the WAF doesn't even have to process it anymore because you've blocked it completely. So that way, the more insight you have, the better for your application, the better for WAF itself, the better for your load balancers, because now you are working in a way that you don't even have to process those anymore. So again, this, in summary, what I'm trying to say is we have all of this in WAF, and if you follow the next set of demo, you will get more hands-on information into how it works. So without wasting too much time, I'm going to hand over to Mohit, who is going to do a couple of demos to show you how WAF will block out this attack. Mohit, you can take over from me.
All right, thanks, Toby. Thanks for laying the groundwork here. Hello, everyone. My name is Mohit Kumar, and good morning and good evening to all of you, depending on where you are in the world. I am also on the same team as Toby. I'm a senior program manager on the Azure Network Security Customer Experience and Engineering team at Microsoft. Our team assists customers with proof of concept deployments of Azure Network Security products, Azure DDoS, Firewall, and WAF on both front door and application gateway. We also collect customer feedback for product teams to drive product evolution based on our customer needs. In this session, as Toby has been talking about the protection and detection capabilities of Azure WAF, we'll now switch gears and do some hands-on attack simulation. The attack simulation we will be doing today is based on the Azure Web Application Firewall Security Protection and Detection Lab tutorial, which is a 4-part lab tutorial that our team has published on the Azure Network Security Tech Community blog space. The short link to it is aka.ms/WAF attack. Before we go into the live demo, let's quickly understand the lab environment we have in place for this demo, the testing process we'll be using, and the attack scenarios we'll be simulating. Okay, so this is what our lab environment looks like. The test environment is, like I said, based on Azure Network Security Demo Lab environment, which is available to all our customers through our GitHub repo, which is aka.ms/aznetsack. As you can see in this lab environment, we have all the Azure Network Security products like Azure DDoS Standard, Azure Firewall, and Azure WAF on front door and application gateway. For this demo specifically, we will be using Azure WAF on application gateway. In this environment, the application gateway publishes a vulnerable web application, which is OWASP JUSHOP, which is a standard web application which is used for security testing. And the idea here is that the Azure WAF on application gateway will protect this JUSHOP web application. The JuShop web application is also exposed directly on the internet with a public URL, which we will be using as a vulnerable endpoint. We also have a couple of spoke VNets here, where we have a few VMs, and we'll be using one of the VMs as our attacker VM for this demo. Now, here we have all the details of how we will be running the attack simulation. If you look to the right of the screen, where we have the environment diagram, on the top right, we have a Kali Linux VM in one of the spokes, which we will be using as the machine from where we run attacks. The Kali Linux VM forwards all the internet-bound traffic to Azure Firewall, which sends it to the internet. Now, the OWASP JuShop web application, which is the target of our attack, is exposed directly to the internet with a public URL as well. And the same instance of the web application is also published through application gateway. So it gives us two avenues: one vulnerable, where the JuShop application is exposed directly to the internet, and one protected, where the same instance of the application is sitting behind application gateway and protected by Azure WAF. So we will show you how we are able to exploit the JuShop application when we access it directly without Azure WAF and path, and also show you how the same attacks are unsuccessful against the same web application when we go through Azure WAF. Now, as I mentioned earlier, the simulation that we will be doing here is based on the Azure WAF Protection and Detection Lab tutorial, which is already published on our Azure Network Security Tech Community blog space. And you can also deploy the same environment in your Azure subscriptions within a few minutes using the ARM deployment template that we have created for you and made available to you through our GitHub repo. Okay, so let's look at the scenarios. We'll be simulating 3 distinct attack scenarios today. The idea is to simulate how a real adversary may go about it, starting from performing reconnaissance or collecting data about a web application, and then moving on to testing and exploiting any vulnerabilities in the web application, and finally exposing and exfiltrating sensitive data. So the simulation has 3 parts. In the recon phase, we'll use an open source web application vulnerability scanner to scan the JuShop web application for vulnerabilities. Then in the exploit phase, we will store and execute an XSS payload on the web application. And finally, in the exfiltrate phase, we will use Sql injection technique to expose and exfiltrate username and passwords from the web application. We will run these 3 attacks against 2 distinct HTTP endpoints, both of which point to the same instance of the JuShop web application in the lab environment. The first endpoint is one which exposes the JuShop application directly to the internet, and the second endpoint is the one behind Azure WAF. The intent is to demonstrate how a web application can be attacked and exploited when it's exposed directly to the internet, because the web applications can have so many different types of vulnerabilities, and exposing them directly on the internet allows the attacker to perform testing or perform malicious actions against the web application in order to identify vulnerabilities and exploit them. And we'll contrast this with how the same web application cannot be exploited, even though it's vulnerable, with the exact same methods when it's protected by the Azure WAF, only with its out-of-box rules. For each scenario, we will also demonstrate how you can use log analytics queries to look up WAF logs and understand how WAF is processing the traffic. We will also show you how you can use the Azure Monitor Workbook for WAF to visualize log data in a more user-friendly way. As a reminder, this entire methodology, start to end, is already documented in the Azure Web Application Firewall Security Protection Detection Labs, and we highly encourage you to check it out and do some hands-on testing. It's quite fun. So without further ado, let's get into the live demo. I will share my browser first and show you the protection and detection lab. So this is where the lab is published. It's on our tech community blog space for network security. The short link to it is aka.ms/WAF attack. When you get here, you will the link will take you to the tutorial overview, and it will give you information about all the different parts. It's broken out into 4 parts, starting from lab setup, reconnaissance, vulnerability exploitation, and data disclosure. And all of the information we will be going through in this demo is based on this lab tutorial. Also want to call your attention to the GitHub repo, our GitHub repo for Azure Network Security, where we have a variety of different artifacts to help you with Azure Network Security products. Some are there to help you automate, some are there to help you deploy, and some are there to just help you look up the data. What I have on the screen is the lab environment deployment template for this specific lab that you can deploy at any time into your Azure subscriptions. Okay, so and also want to show you once you deploy the lab environment, these are all the different resources which will be deployed in a resource group that you choose in your Azure subscription. So I have, in preparation for this lab, I have all the resources already deployed. I've also deployed the Azure Workbook for WAF, which we will be using in our demo as well. So let me bring up my attacker VM. So this is the Kali Linux virtual machine that is in our lab environment. And give me 1 second. The demo gods are not happy with us today, so I'll just take a minute and okay, I need to reconnect. Hopefully all of this will work as expected and we won't have any unintended issues. We've had a small issue this morning, but we found a way to work around that. So the first scenario is in this demo is the reconnaissance piece. And so for reconnaissance, there are a variety of tools out there. Typically, you would use something like a web vulnerability scanner or application vulnerability scanner, which will scan the application and give you a list of all the possible issues and vulnerabilities that it has found. In our case, we are using an open source vulnerability scanner called Nikto. Now, I want to call your attention to the two different application URLs, if you will. So the one on the left of the screen, which is OWASP Direct, is the public URL of the Juice Shop application, which is exposed directly on the internet. There is no WAF in its path, so we can hit it directly. And this name, which is Juice Shop through Azure WAF, is the same Juice Shop web application in our lab environment, but there is WAF in its path, so it's essentially protected by WAF. So, we will be running this test here. Yeah, let's go ahead and run this. And we will be looking at what the output looks like. Want to call your attention to the fact that we've already run this test in preparation for this lab, and as you can see, when we are trying to hit the web application directly, the open source scanner has already identified 2 errors and 119 items, which could be investigated by the security analyst or an adversary to look for vulnerabilities and possibly do some more testing. Now, so this is not up on the screen yet because we've had some issues, like I mentioned earlier. But when we the Nikto scanner, when we're going through the Juice Shop web application through Azure WAF, we will find that there will be 0 errors and there will be about only 2 or 3 issues to be reported here. Unfortunately, it's not up on the screen because we were trying to work through some issues right now. This typically takes about 4 to 5 minutes to run, and so we won't wait for it to run completely, but instead we will go into the logs and start to look at what WAF saw when we ran this vulnerability scanner directly against the ran the scanner against the web application, which is protected by Azure WAF. So let's go into our log analytics workspace, and we can look at the logs. Okay, it's coming up. So as you can see, we have a bunch of logs here, and so it's a very simple, straightforward query. We're looking into Azure Diagnostics and looking for a category where it's application gateway firewall log, and application gateway firewall log is where we have the web application firewall logs. And so you can see there's a bunch of messages here. This request missing except header. There are others here which are buried, like authentication bypass, and things like that. We have a lot of pages, so I'm going to try and pull this up and see if we have other messages which will show up here. Yeah, so authentication bypass, URL file extension, suspicious Java class, SQL injection, because the web application scanner will try to do a lot of different things when it's trying to assess the web application. So it may send requests to different with different delimiters. It may try to inject certain things. It may try to do path traversal and things like that. And all those things we will find in our logs. So common injection techniques, SQL comment sequence detected. So all those things are coming up in the logs. And so this is one way to look at the logs to understand what's going on with your web application. And now let's look at the WAF workbook. And so if we look at this workbook and we change it to last hour, because we ran this this tooling or the NIC to scanner against the web application in last hour, we see that there's like 27,000 requests. The WAF action filter shows us all the requests that were matched and that were blocked. So if we were to just click on the blocked ones, we see these are the top 40 URIs which were blocked. If we were to sort this, yeah, unfortunately, it's not exactly how we had envisioned that this would go because of the issues that we had this morning. But if we look at what I want to show you here is a specific a message which WAF logs show you that there is a security scanner who's trying to do something against the application. Yeah, so here, found user agent associated with security scanner. That's just one of the messages of hundreds of messages that might come up because the security scanner is trying to do so many different things against a web application. But this is a very high confidence indicator which tells you that there is a security scanner out there which is trying to do something against your web application. But there are other things like MySQL comments and SQL injection probings, which are also part of the security scan. Okay, so let's move on to our second scenario, which is cross-site scripting. So like I said, this takes a little bit of time. So while the scan that we were running against the juice shop application has finished, and we still see the same pattern, 2 errors and 119 items. This is still going. From experience, I can tell you that this will report 0 errors and about 3 items, and that's the expected behavior here, because Azure WAF will block a lot of those requests which look malicious, and we can see that there is the server responding here is application gateway. Okay, so then our second scenario, which is cross-site scripting, again, 2 instances of browser, and one is going to the juice shop application directly, which is exposed to the internet, and the other one is going to the IP or public IP of application gateway, which has Azure WAF, and it publishes the same juice shop web application. Now, let's see if we can exploit this web application or inject some cross-site scripting code in this web application, and if it would work. So for this, for doing that, we will go to the customer feedback page, and we already know this because we've done this testing earlier, and we will inject or we will try to inject iframe here, and so let's do that. Give me 1 second. Right. And we'll give it a rating, and we'll say do some math here. Okay, hopefully this is right. No, it's not right. Okay, what's going on? Okay, sorry, I can't do math. Okay, there we go. All right. Okay, so then we've been just sorry about that. So we've written the XSS payload here into the web application, and if we look at what's going on, we try to write this this XSS payload to the web application, and the response that came back. Okay, so it's telling me that okay, yeah. So the response that came back is success. So we wrote this JavaScript, and the response is success. So it means that we were successfully able to write this into the application database. Now, we know that all the customer feedback that's input into the application is shown on the About Us page in this web application. So if we were to go to the About Us page, we want to see if, yeah, so here we see it. We see a pop-up come here which says XSS. That's exactly what we expected to see. And so this shows that we're able to successfully inject and execute XSS payload in this web application when it's exposed directly on the internet. Now we'll try to do the same thing to the same web application when it's protected by Azure WAF. Like I mentioned earlier, this is the IP or public IP of application gateway with Azure WAF, which protects this web application, and hopefully my math will work this time. So we'll go to the customer feedback page and put the same JavaScript. And so hopefully this is right. Okay, so then when we hit submit here, nothing happens, and this is part of the design of the application when when it doesn't want to accept something or it doesn't accept something, it doesn't throw an error. So if we go into our Burp suite, we look at okay, so why is it not being captured? Give me a second. So I just need some configuration here. So basically what I'm trying to do is exclude some noise from this Burp suite capture, and I will add this to my scope as well. So the problem that we had earlier today was that we had a name set up for this public IP, and the name is no longer working. So that's why nothing is being captured in the Burp suite window. So if we go back here and try to do this, hopefully we should see something. Yeah. Okay, so we see it now. And so when we try to input the same JavaScript, which is the iframe in JavaScript, which is supposed to pop up, bring a pop-up and say XSS, we see that the response is 4034 forbidden, which is expected, and we expect WAF to protect against these type of payloads, which might be malicious. So let's go back and look at what's happening in the WAF logs. So again, going back to the our log analytics workspace, the first thing we want to do is we already know that this is the URI to which all feedback is posted. And so if we look at it, we should see something, and we want to reduce that timeline because we just did this test. And I'm going to sort this by our local time. OK, so then if we look at it, we see that this response is blocked, and it is detected as an XSS attack by WAF. And if we scroll further to the right, we see that there's warnings which come up, warnings that come up, and then finally the request is denied. And so we can take one of the transaction IDs here. So every request that comes into WAF is assigned a transaction ID, and that's how you can look up a group of the same request while it's processed by a group of rules. So as Tobi mentioned earlier, every request. So application gateway WAF has something called anomaly scoring, which means that when a request comes in, It is evaluated by a bunch of rules where they could be cross-site scripting rules, SQL injection rules, LFI, RFI rules, and things like that. However, when there's a match, it does not automatically mean that the request is denied or dropped. The request is in anomaly scoring method, the request is assigned a score and then it is passed on to other rules for processing. Now, when the total anomaly score reaches 5 or above, that's when the request is dropped by a mandatory rule. So we see that this is the request, or this is the log which captured the JavaScript that we injected here, or no, not this one. Let's take a look. Yeah, so this is the one. This is the same transaction ID. So as we can see that there are multiple rules who match this request. So if we were to look at, yeah, so match, and then finally blocked. So what's happening here is that different rules are evaluating this request and logging a message. So for example, first message is remote command execution, XSS attack detected, no script XSS injection, and things like that. And by the time we reach to the final stages, there is a restricted SQL character also detected here. And so finally, there is a score of 43, which is assigned to this one request. And so, like I mentioned earlier, in anomaly scoring method, if the request is assigned score of 5 or above, it's blocked. Here we have a total score of 43, and so 43 is based on 25 from XSS rules and 13 by SQL injection rule, and that's why this request was stopped. And if we were to go and look at the WAF workbook, and try to look at this request as well. So let's say last 15 minutes, we see that there is API feedbacks here. This is where we submitted our feedback. You can just come in here and click on this pane, and it will filter out the entire workbook for all requests to this this target. As you can see, we can see all the top 50 event triggers. We can see all the messages, we can see the message details, and essentially we're seeing the same thing that we are seeing in the logs, but within the logs, you have to open the logs up or open each line and see all the details. The WAF workbook basically breaks it out. It has parsing logic, which breaks out the entire logs and lays it out in a more consumable, user-friendly fashion. And so it gives you all the details about, or gives us all the details about the request that we just sent in, what rules process this request, what were the messages, what was the URI, and you can also see other details here, or rule details and message details, again, in the tracking ID messages. Okay, so then we'll move on to our final scenario where we'll be doing a SQL injection. So, and like I mentioned earlier, the Nikto scanner based reconnaissance is also part of this lab tutorial, the Reconnaissance playbook, the one that we just did right now for XSS is part of the vulnerability exploitation playbook. And the one that we're going to do now, which is the final one, is with the SQL injection, is part of the data disclosure and exfiltration playbook. So let's go back to our Kali Linux VM, and here we will again use the same approach. We have two applications, and our two application instances. We'll go back to home, and we'll do a quick search here. And why we're doing a search is because we want to capture the API, which allows search. And we know that this is a vulnerable API, so we will try to inject some SQL injection payload here and see what happens. So we will take this request and send it to repeater. Repeater functionality in Burp Suite basically allows you to replay requests. And so what we will do here is append a SQL query to this URI, so, or this query parameter. Give me a second. All right, so come in here and we will hit go. And as soon as we hit go, we get a response from the Juice Shop application, which is exposed directly on the internet, and it gives us all the data. This is not expected, and it's only coming up because we are doing a SQL injection, and we know that there's an existing vulnerability in this application. And the data that we get back is basically a JSON, big long JSON element, which contains many details. And the most important details for us as somebody as an attacker is the sensitive details that we find here. So, for example, what we have here is all the usernames which are in the web application. So we see admin, we see vendor. These are all the, and there are others as well, or Amy at Juice Shop. These are all the user IDs which are in the web application, or users who are registered in the web application. We also see something here which looks like a long, alphanumeric description, but what essentially this is, this is the user password hash. And so in a lot of web applications, which are insecure, user passwords may be just hashed and stored, but with SQL injection, an attacker may be able to exfiltrate those or extract those from your web application. And for example, for these hashes, these are not directly reversible, but you can use an open source hash reverser or online hash reverser and try to reverse these hashes, and it'll give you the password, right? So that's the problem that you run into with SQL injection, because with SQL injection, in addition to just being able to exfiltrate application-specific data, you're also able to exfiltrate user-specific data, sensitive data from the application, and compromise the users in addition to compromising the application. Okay, so then we've seen how this SQL injection works successfully against the OWASP Juice Shop application, which is exposed directly to the internet. Now let's see what happens when we try to do the same thing against the same instance of web application when we're going to it through application gateway. So we'll do the same thing again. We'll try to search. We'll capture this search in the proxy, and we will send this request to repeater again so we can replay it. And we'll append the same SQL injection code here and hit go. And when we do that, we get a 403 forbidden from application gateway. This is WAF detecting that there's a SQL injection payload and denying that request. So how do we know that? We go back into our web browser where we will look at the WAF logs. So we know that this is the URI where we it injected the SQL injection payload, and if we run it, we will also pull the log. In the interest of saving time, I'll also refresh the WAF workbook in the meantime. Okay, so it takes about 30 to 60 seconds for logs to get refreshed in Log Analytics workspace. So we'll have to give it a minute here, or a few seconds. Hopefully this will work. Nothing yet in logs. Okay, so then while we're waiting for this to happen, I just want to recap that we simulated 3 attack scenarios against a vulnerable web application, which was OWASP Juice Shop. We did that directly to a public URL, which was exposed directly on the internet, and then we attempted the same attacks to the same web application through Azure WAF on application gateway. We saw that we could exploit the Juice Shop web application when it was exposed directly on the internet, and the same attacks were unsuccessful when we attempted them against the same web application through Azure WAF on application gateway. We also learned how to use log analytics queries and the WAF workbook to understand and analyze WAF logs. And as a byproduct, you also learned about the WAF attack simulation tutorial, which already contains all the necessary deployment templates, links, instructions, and everything for you to do simulation on your own. And we strongly encourage that you check it out and do some hands-on testing. So hopefully there is some logs. Yes, there are. Okay. So this is our SQL injection attack, and hopefully it'll show something. Yes. So what we injected in the or what we appended to the URI in the SQL injection attack was a URL encoded query, and if you decode that, this is what the real query looks like. So this is absolutely right. And if we look at the logs and what happened here, right away, WAF detected SQL injection. It saw MySQL code execution and things like that, and it was processed by multiple rules. And by the end of it, there was a total anomaly score of 43, which was assigned to this request, and all by SQL injection rule, because this was a pure SQL injection attack. And if we go into the workbook, we can see that this request will now show up because, okay. Let's hope it shows up. Okay, it's still thinking about it, but essentially you would again see the URI here, which is REST product search, show up in the top 40 blocked URIs, and you can click on it and see all the details of the SQL injection attack. I'll try to refresh it one last time, and hopefully it'll work. I know we are almost on time. Okay, so it's, but I hope everybody gets the idea here. It's there is a little bit of lag, and the URI is expected to show up, and when you click on it, you can see all the details as we showed you for the other attack. Going back to our slides, here are some key takeaways. Number one, Azure WAF can protect against a variety of web application vulnerabilities and attacks with its out-of-box rule set. No customization needed. In our lab environment, there's no customization in Azure WAF. It's all the attacks were being protected with out-of-box rule set. If you have web application or even APIs in Azure, you should protect them with. You should use Azure WAF to protect them. And protection can be enabled at a global network edge with WAF on Azure Front Door, and also at a regional level with WAF on Application Gateway. So that's all we have for you today, folks. Thank you again for taking the time and learning about the great protection and detection capabilities of Azure WAF with attack simulation. You can also do this on your own with the lab tutorials and the pre-built lab deployment template and instructions in our lab tutorial. With that, we have a couple of minutes and we'll open it up for any questions.
Thank you, Mohit and Tobi, for such a great presentation. And guess what? The demo gods were with us. So we made it, despite the issues we had in the morning. So happy to see the outcome. I think all the questions were answered. Let me just check here, the last minute thing. Oh, there is one. So is there a LA workspace with sample data for us, or do some experiment from? Joe is asking.
I'm not sure if I totally understand the question. Are you asking that if there is a log analytics workspace where we may have all the possible types of WAF logs already in place, so you could do some analysis on it? Is that the question?
I think that was the question, Mohit. And there is a publicly accessible log analytics workspace with generic data so that you can just practice KQL and get a feel for it. But I don't believe that that workspace has WAF specific logs. For that, I would recommend just going through the same tutorial as Mohit showed today and generating your own attack data and using what you learned from the generic log analytics workspace data to query it.
Okay, and I see that Ashish already shared the lab link. That's great. Thank you for that. And so I think that was it. And I would like to notify the audience on an update we made regarding the June 17 webinar, where we had initially announced a Better Together webinar on Azure Security Center and Azure Purview. But due to unforeseen changes, we are going to host a Better Together story of end-to-end sensitivity label flow from Microsoft 365 to Azure Purview, and then to SQL and all the way to Power BI. So that's the update on that. And also would like to remind the listeners that the best way to ensure that you don't miss any future webinars or major announcements, to please visit our landing page at aka.ms/security community. And while you're there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. Just like we shared links today in regarding the Azure network security, you'll find there bit-sized product videos, ninja trainings, recordings of past webinars, as well as the links to the different GitHub communities relevant to the product. And we'd love to hear your feedback on how we can improve on these webinars. And please do so by taking a minute and going to aka.ms/security webinar feedback. In case we missed your question or you have additional questions post this webinar, please visit the Azure Network Security Forum at aka.ms/Azure Network Security Community. I want to thank all of you for being part of our community and for joining us on these webinars. So we hope to see you next time. Goodbye.